here we have an equilateral triangle ABC. Inside that triangle we have two circles, a larger circle here and a smaller circle here. What we need to find is the ratio of the areas of the triangle and the smaller circle. Now there is a small problem here. If you look at the bigger circle, it touches all the three sides of the triangle, which means it qualifies to be called a incircle, and we can find what the in radius is. But then unfortunately this smaller circle touches only two sides. So let us work with what we have. Let us first start with the in radius of this triangle. Now let the sides of this equilateral triangle be A units. Then what is the formula for the in radius? It is area by semi-perimeter. Here we have an equilateral triangle with sides of the measure A units. Then what will be the area? It will be root 3 by 4A square. What will be the perimeter? The perimeter will be 3A. But what we need is the semi-perimeter divided by 2. And the answer you are looking for is A by 2 root 3. That is going to be the in radius. Now let us construct the altitude for this triangle. So now I have constructed the altitude AD for the triangle ABC. It is an equilateral triangle with sides of the measure A, which means the altitude is going to be what? It is going to be root 3 by 2A. Now you can see the way I have drawn it. The center lies on the altitude. The in center lies on the altitude. Is that correct? Is that possible? If you know, the in center is the point of intersection of all the angle bisectors, not the altitudes. It is the point where all the angle bisectors intersect. The point where all the altitudes meet is the orthocenter. But then why have we drawn it like this? Because what we have here is a symmetric figure. It is an equilateral triangle which is symmetric, which means what? If you draw any altitude, it is going to multitask. This altitude is also going to be the median. It is also going to be the angle bisector. It is going to multitask. So your in center and your ortho center is all going to be same. So this picture that you see here is perfectly fine. We can locate the center, the in center on the altitude. Now the place where these two circles meet, let me name it R. And through that R, let me construct a common tangent, and I will name it PQ. Now this triangle APQ is going to be an equilateral triangle. Can you tell me why that is? If you look at this circle, the in circle, what do you notice? RD is its diameter, and this PQ and BC are two tangents on the ends of a diameter. Then what do we know about such tangents? Tangents which lie on the end points of a diameter. Such tangents are going to be parallel, which means what? Corresponding angles are equal. It is an equilateral triangle, right? So here you have 60, corresponding angles are equal. So here you have a 60. Here you have a 60, means here you have a 60. And the third angle, the common angle, is 60. So APQ, all three angles are 60, which means it is an equilateral triangle. Also, this is an altitude. Here you have a 90 degrees, which means here also you have a 90 degrees, which means what? AR is its altitude. But then what is AR? AR is equal to AD, this whole thing, minus RD. What is AD? We know it is root 3 by 2A. What is RD? We know the in radius is A by 2 root 3, but what we need here is not the radius. What we are looking for is the diameter. So multiply that by 2 and you get A by root 3. So there you have another equilateral triangle and you have another altitude. So there we have two beautiful equilateral triangles. We know that the side of the bigger triangle is A. What we need to find is the side of the smaller triangle. Now, what do we know about their altitudes? The altitude of the bigger triangle is root 3 by 2A, and the altitude of the smaller one is what? It is A by 2 root 3. Then what is their ratio? If you look at their ratio, is going to be 3:1. Now this is the ratio of the altitudes. Then that means the ratio of the sides is also going to be the same. Can you tell me why that is? If you have two equilateral triangles of sides of measure m and n, their altitudes will look like this. So you can see that the ratio of the altitudes is also m:n. The sides is also m:n. So whatever is the altitude ratio, that is going to be the side ratio as well. The bigger triangle has sides of measure A. That means the smaller triangle is going to have sides of measure A by 3. That brings us to the in radius. If the triangle has sides of measure A, the in radius is what? It is A by 2 root 3. And if this is if this for the smaller triangle, if this is the side, the in radius is going to be what? There. This is going to be the in radius of the smaller circle, and this was the in radius of the bigger circle. We do not need the bigger circle. What we need is the area of the smaller circle. This is the in radius of the smaller circle, which means what is its area? Area of the smaller circle is going to be Now let's find the ratio. So the ratio we are looking for is this. This is the ratio of the areas of the triangle to the area of the smaller circle. That is all for today. Take care. Assalamu alaikum.